we're going to do this problem out, and I'm not going to read it. You can read the problem. The given information is that we have 1.0 times 10 to the 3 atoms of silver. And we want to find out what's the mass of that. So the given and the unknown is that. How many grams of silver do we have? Well, we learned in class today that we know 1 mole is equal to 6.02 times 10 to the 23rd things. But we also know that 1 mole can describe the molar mass in grams of those things. So the molar mass in grams is equal to 1 mole and is also equal to 6.02 times 10 to the 23rd things. So up until now, we've done conversions this way: moles to grams, grams to moles. We've done conversions this way: calculations, moles to things, things to moles. And now we're going to use this in a way where we can go directly from the grams to the count. And since they're all equal, I can use any two of these as a ratio to convert from one unit to a different unit. So if I say that we started with 1.0 times 10 to the 3, which is just 1,000 atoms of silver. So 1,000 atoms of silver is a lot less than a mole of silver. And we want to find out how many grams of silver that is. So I'm going to remind myself, I'm going to put grams of silver way over here. Well, I want to take these 3 items and make a fraction that equals 1. Since they're all equal, I can make a fraction out of any of them that equals 1. That will cancel atoms and give me grams. Well, if I want atoms to cancel, I know that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So I'm going to put 6.02 times 10 to the 23rd atoms of silver. That goes on the bottom, so atoms of silver cancel. And I could put 1 mole up here, but then I'd get to moles, and then I'd have to convert from moles to molar mass. So I can skip that step, and I can say, well, 6.02 times 10 to the 23rd atoms is equal to a mole, which is equal to the molar mass. And the molar mass of silver is 107.87 grams of silver. So now if I do my canceling of units, atoms silver cancels atoms silver, and I will end up with grams of silver, which is what I want, so I'm doing this correct. And when I do that calculation, I get an answer of 1.79 times 10 to the minus 19. So if I round to 2 sig figs, because the problem gave me that, 1.8 times 10 to the minus 19 grams of silver. Okay, we'll go through a couple of these quickly as well. Okay, so we have 31 grams of gold, and we want to know how many atoms of gold it is on this first problem, and then we'll worry about the cost question later. So 31 grams of gold. I want to get to atoms of gold, so I could use moles per gram. I could use the molar mass to get 1 mole is equal to a certain number of grams, but since I know the molar mass of silver is 196.97 grams, I'm sorry, of gold, rather, this is the gold problem. So I can cancel grams of gold, and on the top of this fraction I can either put the word 1 mole, or I could put the equivalent number of atoms, which is what I want, 6.02 times 10 to the 23rd atoms of gold. That way, grams of gold will cancel grams of gold, and I'll find out that 31 grams of gold is equal to 9.47 times 10 to the 22 atoms. 9.47 times 10 to the 22 atoms. Okay, so now we know 9.47 times 10 to the 22 atoms of gold. That's what that 32 grams is. And we can buy that number of atoms of gold for $1,300. So if I think of it that way, if I multiply this by, say, $1,300, that means I would get that many gold atoms, because I can buy that many for $1,300. If I multiply this by 2,600, I would get twice as many gold atoms. So if you have an amount per dollar, if you multiply by the number of dollars, then you can find out how many of that item that you would get. Like if I could buy 1 pair of shoes for $10, so 1 pair of shoes over $10, and I multiplied that by $40, I could buy 4 pairs of shoes. So in this case, we're going to multiply this by 1 cent. Well, it says how many gold atoms could you buy for 1 cent? So I'm going to multiply this by a penny. That's $0.01. And when you multiply that by a penny, you find out you still get a lot of gold molecules. You're going to get 7. You're going to get 7.3 times 10 to the 17. So the answer would be 7.3 times 10 to the 17 atoms of gold for a penny that day. And let me just erase that 9. Doesn't want to erase. Okay. Now, the next question here is the mole ratios we were talking about. And this axle conversion, you don't need to worry about that word axle conversion. Essentially all this is saying is if you have N2O4, so for every 1 mole of N2O4, you would have 4 moles of oxygen. That's all these questions are asking for. And if I have 1 mole of NO2, right? 1 mole of NO2 has 1 mole of N. So this is similar to what we did in class. I just didn't use the word axle, and I'll explain that. It's just a different visual to use. 2.3 moles of CO2, right? So if we were to do it like we did in class, 2.3 moles of CO2. And we know that there's 2 O's in every 1 CO2. So we can cancel CO2, and we find out that that's 4.6 moles of O. So that would be 4.6. Okay, so the QR codes are helpful too, so you probably should take a look at those as well. One last thing is oxalate. That was not one that you had to memorize. Oxalate is an ion. It's C2O4, and it has a 2- charge. So calcium oxalate in this compound would be CaC2O4. And the question is, how many moles of carbon are in 52.4 milligrams of calcium oxalate? So actually, I'm going to do that one on the next page. Okay, so we're given 52.4 milligrams of calcium oxalate, and we want to know how many moles of carbon. Well, if we look at the chemical formula, we know that there's 2 moles of carbon for every 1 mole of calcium oxalate. So in order to answer this question, we need to know how many moles of calcium oxalate we have. And in order to find the number of moles of calcium oxalate, we're starting with a mass. We're going to have to use our molar mass. So we're going to start with 52.4 milligrams of calcium oxalate. So be careful, that says milligrams. So before I can do anything, I need to switch that to grams. So I'm going to say that 10 to the minus 3 grams is equal to 1 milligram. And now I have the right unit to do my molar mass. So now I'm going to multiply this by, I have grams on the top, I want to know moles, so I'm going to say 1 mole of calcium oxalate is equal to 128.08 grams of calcium oxalate. Sorry, I'm squishing that in there. So now if I cancel out my units again, grams of calcium oxalate is going to cancel grams of calcium oxalate, and I have moles of calcium oxalate. I want moles of carbon, so I'm going to put 2 moles of carbon is equal to 1 mole of calcium oxalate. Moles of calcium oxalate cancel moles of calcium oxalate, and we're left with moles of carbon, which is what I was trying to solve for. And when you multiply that across, what you will find out is that you have 8.18 times 10 to the negative 4 moles of carbon. You had 4.09 times 10 to the negative 4 moles of calcium oxalate, but you have 8.18 times 10 to the negative 4 moles of carbon.